Hi friends, in this video we are going to derive an expression for the electric field due to an electric dipole at an axial point. So let's suppose we have this dipole and the point P is a point on its axis. In this dipole, the distance between negative and positive charge is 2a, and let's suppose the distance of point P from the center of the dipole is x. So now we know that the electric field due to a positive charge is directed radially outwards and the electric field due to a negative charge is directed radially inwards. So let's suppose E plus bar is the electric field due to positive charge plus Q, and E minus bar is the electric field due to the negative charge. So at point P, the E plus will act radially outwards from positive charge. So that is in this direction. So this is E plus bar, and E minus will act radially inwards towards the negative charge. So it acts in this direction. And the net electric field due to this dipole at this point will be vector sum of E plus bar and E minus bar. Okay. So let's write net electric field at P, let's call it E axis because it is electric field at an axial point. So E axis bar is equal to E plus bar plus E minus bar. Okay. Now we know from the last video that the electric dipole moment due to an electric dipole is directed from minus q to plus q, and it is denoted by P bar. Okay, and its magnitude is P, which is equal to magnitude of one of the charge multiplied by distance between the two charges. So here we can see that the E plus bar is directed in direction of the electric dipole moment P bar, and E minus bar is directed opposite to that of the electric dipole moment. So let's write E plus bar and E minus bar in terms of their magnitudes and electric dipole moment to show the direction. So the magnitude of E plus bar will be 1 over 4 pi epsilon naught times Q over distance of positive charge from point P, let's call it R plus. So R plus square, and it is directed in direction of the electric dipole moment. So P cap. Okay. And E minus bar is 1 over 4 pi epsilon naught times Q over R minus squared. So this is the magnitude, and it is directed along P minus bar. So we show this unit vector P cap to show the direction and put negative sign in front of the charge. So now from this we can take 1 over 4 pi epsilon naught times Q common. So I can take Q over 4 pi epsilon naught and P cap also common from these two terms. So I am left with 1 over R plus squared and this negative sign from here minus 1 over R minus squared. Alright. Now let's see what is R plus and R minus. So R plus is distance of point P from this positive charge, and the distance of point P from the midpoint of dipole is x, and distance of positive charge from the midpoint is a, and that means distance of p from the positive charge is this distance minus this distance. Okay, so it is x minus a. And similarly, for this negative charge, the distance of point P is x plus this much distance, which is a. So r plus is x minus a and r minus is x plus a. Okay. So we have q over 4 pi epsilon naught into p cap times 1 over r plus is x minus a. So 1 over x minus a squared minus 1 over x plus a squared. Now we can multiply this term by x plus a squared and this term by x minus a squared. So we have q over 4 pi epsilon naught times p cap multiplied by x plus a squared minus x minus a squared, and in denominator we will have x minus a squared multiplied by x plus a squared. Then we can expand this to get q over 4 pi epsilon naught times p cap. X plus a squared is x squared plus 2 times x into a plus a squared minus x minus a squared is x squared minus 2 times x into a plus a squared. And in denominator we have same thing, x minus a squared multiplied by x plus a squared. So I will write it as x minus a times x plus a squared. Okay. Then in numerator this x squared and minus x squared gets cancelled out. A squared and minus a squared gets cancelled out, and we are left with q over 4 pi epsilon naught times p cap multiplied by 2 times x into a and minus minus plus 2 times x into a, which is 4 times x into a. All right. And in denominator we have x minus a into x plus a squared. So we know x minus a times x plus a is x squared minus a squared. So I can write this as x squared minus a squared and square of that. All right. So this is electric field along axis of an electric dipole. Now we'll write this in terms of the electric dipole moment. So we know that magnitude of electric dipole moment is q times 2a. So in the numerator we have q multiplied by 4 times xa, and I will write this as q multiplied by 2a multiplied by 2x. So 2a into 2x is 4 times xa, and in denominator we have 4 pi epsilon naught multiplied by x squared minus a squared and square of that. And we have this p cap also. So let's write p cap. And then we can see we have the magnitude of the electric dipole moment, which is q times 2a, and a unit vector in its direction. So we can replace this by p bar. Okay, so P bar is equal to the magnitude of electric dipole moment P q times 2a multiplied by a unit vector in that direction. Okay, so we can rewrite this as, I will write 2 times P bar into x divided by 4 pi epsilon naught multiplied by x squared minus a squared and square of that. So this is the formula for the electric field due to an electric dipole along an axial point, which is at distance x away from its midpoint. Okay, so from this formula we can conclude that the electric field due to an electric dipole at an axial point is directed along the electric dipole moment of the dipole, and what it means is, if we keep a small positive charge over here on the side of this positive charge, then it gets repelled by the dipole, and if we keep it over here on the side of the negative charge, then this positive charge gets attracted by the dipole. Okay, now next let's treat a special case. So as I told in the last video, that in practice we deal with very small dipoles, that is atoms and molecules, and for them this distance x is very large compared to length of the dipole. Okay, so the special case is when x is very large compared to a, and if x is very large compared to a, x squared is very large compared to a squared, and therefore we can neglect this a squared in the denominator. Okay, so doing that we get E axis equal to 2 times of P bar into x over 4 pi epsilon naught multiplied by x squared because we have neglected this a squared, so x raised to 4, and then we can remove one x from this x raised to 4 and cancel it with this x, so we are left with x raised to 3 in the denominator. So 2 times P bar over 4 pi epsilon naught multiplied by x raised to 3. Okay, so this is the formula for the electric field due to an electric dipole, a small electric dipole at a point on its axis, which is at distance x from its midpoint.